What's up, everyone? Welcome to another episode of the Blaspheming Bite. We're doing a Google-based question from Leetcode. It's called the validate stack sequences, and the question goes like this: you're given two sequences, pushed and popped, and you're given a distinct value. So you're assured that all of the values that are there in pushed will be there in popped. And what pushed and popped means basically is that you're pushing values into a stack and you're popping values from the stack. Now you have to figure out whether the sequence that is given by the pushed sequence and the popped sequence, whether that's correct. Now the reason why I'm doing this question is because the solution is not given very well in some of the YouTube videos that I saw, and I felt that I could do a better job. So let's see whether I can explain this. So what do you have to remember when you're trying to do a problem like this? Okay, before we go into that, into the actual problem, let's just try to do something. Okay, I have a list of values here, and it's going to be like 1 3 5 4 2. Okay, now and this is a sequence in which I'm going to push items into the stack. Okay, and imagine stack is over here. Now what's the first thing that you have to remember about a stack? If you want to pop an element from the stack, it has to be at the top, right? What happens when you pop an element in a stack? The top element goes out of the stack, right? So let's say, for example, you put 1 into the stack here, and you put 3 into the stack. If I go and say that I want to go and pop 1 out, like let's say that my sequence right now looks like 1 here, I wouldn't be able to do that, right? That would be a foul on my part. Yeah, I would be able to do something like, so if I had 1 and then I popped it out, yeah, that's actually possible. So in this case that is possible, but let's say that we had something like 1 and then I pushed 3 in. Okay, let's do it this way. So let's say I pushed 1 in, and then yeah, I didn't pop that out. I pushed 1 in, and then I pushed 3 in. Okay, and then I'm trying to say that I actually pop 5 out first. Would that be possible? Yeah, that's actually possible. So the only thing that you have to take care is that you have to make sure that 5 was pushed in initially. Okay, let's assume that we this is where we've gotten so far, right? So we've popped out 5, and now if my popped sequence looks like this, would that be possible? Can I do that? No, because if I've popped out 5 and that's a valid thing, that means that I've come all the way here. Okay, and then I've popped out 5, then the next thing that's on the top of my stack is actually 3. So there's no way that I can pop out 1 right now. So that's the idea that we have to think about. Like any time that you see something in the popped sequence, you have to make sure that it's at the top of the stack. Okay, that's like the basic thing that you have to remember. Now going back to one of the examples that we have, let's try to see let's try to break that down. Okay, now one possible sequence that I could do here would be, hey, let me just put everything 1 2 3 4 5, and then let me start popping out. Now that's not going to work, right? So you have 5 here, you're comparing it for the first element that's popping out is actually 4, but that's not valid, right? So what you're going to do here is that until you get to the value of the first popped element, you're going to keep pushing elements from the push stack. Okay, you're going to keep pushing 1 2 3 4 5, and you reach over there, and then every time you push something in, you're going to check, hey, where's my pop at what pointer is that, and does that match? Because any time, like I mentioned earlier, anytime the top of the stack has a value that's in the popped, like that can be popped, that is poppable, then you have to pop it out. So for example, in this case, you have reached 4, so and that is in the popped queue, so you can do that and then you can move that. Now in the next one, you're going to check the top of the stack is 3, and you compare it with 5. You compare it with 5. Is that equal? No. So what are you going to do? You're going to jump this over here. You're going to add 5 there. Oops, my bad. You're going to put 5 over there. Okay, and then you continue this process. So at this point, you can see that 5 and 5 are the same. So you're going to pop that out, and then you move your pointer, and then 3 and 3 are the same. So you're going to pop that out as well. And right now your popped counter, your popped array is at 2, and then you can pop the values the same and same, and finally you are left with nothing in the stack. Okay, now the important thing to remember here is, how do we know for sure that we've extinguished everything like that? Okay, when the stack is empty here, but I'll create a case where the stack might be empty, but I've not really reached the end of my sequence, right? So in that case, what do I do, right? So there, what I'm going to do is I'm going to make sure that my popped has reached all the way till the end. Okay, it has to reach all the way at the end. Okay, because if it doesn't reach all the way till the end, that means that I've not extinguished all of my values. So that's actually not possible. There's no scenario where your stack would be empty, where your stack is empty, but you've not reached the end. So that's not a possibility. It won't reach there. Yeah, so because of that property, you can use that as a condition for when you return. So you can either look at, hey, has my popped reached the very end, or you can say, you can check, hey, is my stack empty? Basically, what do we want to do? We want to use the popped array to make sure that if we ever whatever we push in it can be popped out, right? So that's the whole idea. So there are two ways of looking at whether this actually works. Okay, the first thing would be to check, has my popped counter reached all the way to the end? That's one way of doing it. And the second way of doing it is to check if the stack has become empty. Because if the stack has become empty, that means that all of the elements are in a particular order, such that I can all of the elements that I pushed in can be popped out. Now let's look at one more example before we quickly move into the code. This is an example where it is bad. Okay, and let's just quickly go through this. So I'm pushing 1, 2, 3, and 4. So at 4 I see that, so I pop 4 out, and then I have 3, so I pop that out, and then I have 2, no, then I have 5, and so my counter has reached over here, which is 5, and 5 and 2 are not the same, so my counter was actually over here. Oh, actually I can do that. So 5 and 5, and that's, so I put 5 and then I remove it immediately, and then my pointer comes to 1, right? It comes over here, and at this point 2 and 1 do not match, and there's no way I can pop 2 out of here. Okay, so because of that, two things: one, I've not reached the end of my popped array, and two, my stack is not empty. There's something in my stack, so I will send that as a result and say, hey, because of that I can't do this. Now looking at the code, what we're trying to do here is you're pushing every element that you see in the pushed array. Okay, so whatever you see coming into the pushed array, you're going to push that in, and then anytime you're going to go through the array, you're going to go to the stack and you're going to check if the value that's on the stack, the top value on my stack, is that equal to where I am currently in my popped array? And if it is there, then I'm going to pop that value out, and I'm going to increment my popped array iterator, or the position counter. And then finally, you can use return stack.empty as a condition. That works perfectly fine. Or if you don't like that, you can use JSQL have you reached the end of the the popped array. And that's the question, my friends. I hope you've got a better understanding of how to do it. So the basic idea is, anytime you want to pop something out of the stack, you have to make sure that the element that's on the top of the stack, you can only remove that. Like basically, you can't pop out the second last element in the stack, or the third last in the first element. No, you have to go in the order. So that's our clue there. Like, look at the top of the stack, look at the current position of the popped array, and if that matches, then you can pop and then keep going downwards. Yeah.